everyone, it's Actuary Dude over here. Let's check out another question. A motor manufacturer is to develop a new car model to be produced from the 1st of January 2002 for 6 years. So that's this bit over here, 6 years until the 31st of December 2007. The development cost will be £33 million, so 18 million will be on the 1st of January 2000, 10 million 1st of July 2000, 5 million on the 1st of January 2001. The production cost of each car is assumed to be incurred at the beginning of the calendar year of production and will be £9,000 during 2002. The sale price of each car is assumed to be received at the end of the calendar year of production. Both the production cost and the sale prices are assumed to increase by 5% on the 1st of January. The first one will start on the 1st of January 2003. It is also assumed that 5,000 cars will be produced each year and that all will be sold. The sale price for the car produced in 2002 is £12,100. So what is the discounted payback period with an effective interest rate of 9% per annum? Okay, so heaps of stuff in there. So I've decided to draw this little timeline over here. And okay, let's get started with our equation over here. So this bit over here, £18 million at the very start, that's what it is. So looking at it, an equation of value is 18 by itself minus, and then there's £10 million that we've spent, but that was in half a year's time, so we can discount that back by half a year. And then we're spending £5 million in exactly a year's time, so we'll discount that back 1 year. So that's really it for that bit. That's fairly straightforward, doesn't take too long to work out. Now with this bit over here, so in order to find a growing annuity, and I don't think I've done any videos when it's growing in a geometric series, essentially the expression that we're going to be needing is going to be looking like this. So 1 minus, which is then 1 plus the growth rate, in this case 0.05, divided by 1 plus our effective interest rate, or rate of return. And so then this bit is, I guess, compounding however many periods. And then we're dividing that all by the interest rate minus the growth rate over here. So in actual fact, how it's going to look for us is going to be 1 minus 1.05 divided by 1.09, which they've given us, to the power of n, divided by 0.09 minus 0.05 is 0.04. And that's what we're going to be needing over here. So let's just see what we've worked out. Now this bit over here we've written 12,100, so that's right there, but that 9,000's got to go up by 5%. These have got to go up again 5% each year, so it's not exactly right, to be honest. Now let's just work out how much money we're going to be getting with 5,000 cars. So I'll just quickly bring up Excel and say, so in the first bit we've got 12,100, equals 12,100 times 5,000 cars is that amount. And so we can just do that divided by a million, so we're looking at 60.5, and then we've got £9,000 that we're spending times 5,000 cars is that, and it's the exact same thing, so that looks like it'll be 45 million over there. So that's what we've got. So we can actually make this equal to, and we can say 60.5, and then we got minus 45, and I'm actually leaving a bit of a gap because we're going to have to discount this back again to get it to this point in time, which is where we're trying to get to. Okay, we're not trying to get to this point or anywhere in the middle. So we've got that bit there, and in order to find the present value of all those cash flows, sorry, I've actually got to leave a bit of space over here. Present value of all those cash flows, we've then got to multiply it by this bit over here. So I'll actually just cut that bit out, if I might, just make things a bit easier, and then just really put that bit in, if I can, right there. So that should make things quite a bit easier. And so then with this over here, all we really have to do, actually there's one more little bit that I have left out, and that is, so I can actually get rid of this bit here. One more thing that we have to do before we can just start solving all of this is that we need to discount this bit back. Now what we're doing with this equation, with this expression bit over here, is that we are going to find the present value of our 1200s right up to this point. So that's good, but we've assumed, that was the 9,000 there, but then we've forgotten the fact that we're receiving 9,000 at the start. So in fact what we're doing with all these 9,000s is we're discounting those back to this point over here, to this year. So we need to discount all of our positive cash flows, the 12,100s, back 2 years. So it's to go back to 0 there. So that's going to be times V squared. And we've got to discount our outflows, the 9,000s. We've got to discount that back just 1 year, right there. And that's how we do it. And so now all we have to do is just solve for n, which we could really use with solver or anything. But let's just try and work that out because we're pretending that we have a calculator with us. So what was the first thing we needed to do? I'll first find out what v is equal to. So I'm going to say equals to 1 divided by 1.09, and that's v. And now let's find our expenses. So our expenses is going to be, I'll actually start doing it here. So then that's going to be 18, that's then going to be 10 times, equals 10 times v to the half. And then this one's going to be, so then we got equals 5 times v. So the sum of all of that, and this is our total expenses over here. And now we can find out, I wonder if I can just, there we go. Now we can find out what our positive cash flows are. So the first bit is we're actually going to have to divide our expenses by this bit over here. So I'll just drag this down a little bit and say, sorry, my Excel's acting a little weird. So here we go. So it's our expenses divided by 60.5 times, we're discounting back 2 years, minus 45 times discounting back 1 year is equal to that. We then have to multiply this by 0.04, and from there we're then going to find equals 1 minus that answer. And then in order to find the next bit, we have to take the natural logarithm of that and divide by the natural logarithm of this little inside bit over here, which is actually our new v, or our new well, I guess the discount factor. So is equal to the natural log of this bit over here divided by the natural log of 1.05 divided by 1.09 is equal to that. So in fact, this is how many years it takes, 3.83 years to get back to this point. So here's 1, 2, 3 point something years over here. But in actual fact, there's two things. We've got to add on the 2 years that we're going back for all of these payments. So over here we've got to, as in we found the present value over here, we've got to go back 2 years to get to here. And then we've also realized that we're only receiving our positive cash flows at the end of the year. So that 0.83 doesn't really make a difference to us. It's the end of the year which counts. So we actually have to round it up to the next year. So we can say, first of all, plus the 2 years that it takes, because that's 5.83 years. 5.83 years will get us from, so over here, 1, 2, 3, 4, 5 to over here. And then it's actually in our 6th year over there. So there it is. N is equal to 6 years. Okay, next bit is, without doing any further calculations, explain whether the discounted payback period will be greater than, equal to, or less than the period calculated in I if the effective interest rate was substantially less than 9 per annum. So I just like to look at it like this and say I do know that they have a negative relationship like this. So if we're saying here's 9 and now we're actually going to decrease it substantially to whatever, even if it's to 8, then we're going to be increasing our present value. So if we're going to be having more money, then in actual fact it's going to take less time to receive that amount of money. And if that's the case and it's going to be taking less time, then our discounted payback period, the N, will be less. So we'll say if I decreases, then we're saying that the discounted payback period will also decrease. So there you go. Thank you very much for watching.